Well, today we're talking about the history of the periodic table and why all the elements are laid out the way that they are. Have you ever wondered why the periodic table looks the way that it does?
Yes, it seems really random.
It does, and it seems kind of scary when you first look at it. There's a whole bunch of numbers and letters and all that, but it's really laid out in a way that makes sense once you understand how it got to be that way. One of the first scientists who did work on the periodic table, his name was Mendeleev, and we call him the father of the periodic table. He had a lot of ideas for the way that things should be laid out, well, the way the elements should be laid out on the periodic table. He's the father of the periodic table.
He's got to be Russian. Mendeleev. Yeah.
Probably.
Russian scientist. Yeah.
And he organized the elements by mass, by increasing atomic mass. So from like left to right on the periodic table, like the masses went up. And when he did it that way, he also kept the properties in mind. So the elements that behaved similarly wound up being next to each other.
Oh, so that's why it's not just a big line of elements and increasing.
Right, yeah.
Okay, so
a bulleted list, yeah.
So that's kind of why it looks a little chunkier in different areas?
Yeah, there's more elements in some groups than in others. He wanted them to be together based on property and increasing atomic mass by properties and increasing atomic mass. Do you remember what properties are?
So, talking about properties, that's just interesting qualities that these atoms might have. So, something like maybe these atoms over here are this type of compound or element is flammable, whereas something else may not be.
Yeah, elements that are really, really reactive get grouped together, and elements that are not very reactive get grouped together. Metals get grouped together, and so on. But his main idea was that they should be organized by mass. And whenever he made his first draft of the periodic table, he even left blanks because he knew that there was going to be some element that would get discovered later that would fit in that spot.
Oh, that's very cool.
Right? He was a very, very smart guy. Another guy, after Mendeleev, his name was Moseley. He had different ideas. He thought that elements should be organized by increasing atomic number. When Mendeleev was doing the periodic table, he didn't know about protons yet. But Moseley did. So once we learned about protons, then he decided that that's how they should be organized.
Right, that makes sense. So they still kind of increased by mass.
Yeah, but it was mostly by protons first.
Mostly by protons first. And then he also kept in mind the properties that Mendeleev had.
He did, and it kind of worked out pretty crazy. Once he laid them out by increasing atomic number, the properties kind of organized themselves like anyway. The elements that had similar properties wound up being grouped together.
Oh, wow.
Yep.
So, if they organize themselves, does that mean that, because I can see that they go up and down, and they go left and right. Are they organized by properties vertically or horizontally?
Vertically. Vertically, yeah.
Okay.
You might think that, protons, like the number of protons, the atomic number, might have something to do with their properties, right? What's going on in the nucleus. But, so elements, we can pull out our periodic table here. Elements are grouped together by properties vertically. So elements in a group all behave similarly.
So a group is kind of like this one line right here, up and down. So it's like a column.
Yes, yeah. The columns are groups.
So what would I call them side to side?
These are periods. So rows are periods. So we could call these groups, and then on the side I'll put periods.
Oh, I see. So because they're repeating these qualities every time they come back, they're periodically showing the same quality.
Yeah, there you go. Because the atomic number increases when you go left to right. All right, we got 1, and then over here we got 2, and then 3 and 4 and so on. The atomic number increases this way. but the qualities and the properties are organized vertically. So whenever you put them in order of increasing atomic number, the properties and the masses kind of organize themselves. The mass increases when you go from top to bottom on the periodic table and from left to right.
Oh, okay. So it's a lot more organized than it looks.
Yeah, it really is. It's kind of crazy. So we have to name these groups, right? Then we're going to name the elements that have similar properties. These guys, we call this group 1, right?
Mm-hmm.
It's got a 1 right there. Group 1 is the alkali metals. And these guys here, they are very, very, very reactive metals.
Yeah, I'd heard that some of them you can't even find in nature.
You can't, because they'll never be by themselves. Every time they come in contact with another element, they have to react with it. Right?
React with it, yeah.
For the most part, yeah. So they don't occur very often in nature. And we're not really...
purely, at least.
Not
I mean,
purely,
they're in compounds, but you can't find them as a pure substance in nature.
Right. Like, this is sodium, right? You know sodium chloride, that's salt, table salt. But pure sodium by itself, you're really not going to find anywhere out in nature all by itself. And we're not really even allowed to have a lot of these here at school because they're just so dangerous. They're reactive. And then the second group, group 2, those are the alkaline earth metals.
See, these two I always mix up because they sound the same.
They do sound very similar, yeah.
So one trick that was told to me is that the alkali metals is the first one because it's one word, while the alkaline earth is 2 words. So it's in group 2.
Yeah.
Yeah,
that's right.
That always helped me out.
And these 2 groups are what we use to make salts a lot. They combine with nonmetals to make salts. So you'll see them a lot whenever we talk about acids, bases, and salts later on in the year. And then these guys in the middle, we're not going to talk about a ton this year, but they are the transition metals. That's where you have a lot of the metals you've probably heard of, like iron and cobalt, nickel, copper, silver, gold. These are all our most common, like, heavy metals. And they are called transition metals.
Oh, okay. Now, I did notice that there seems to be a line starting right after 56 right here, and then it branches off to these down here. Are these associated with these? They
are, and actually, so these down here, the lanthanides and actinides, we'll call these rare earth metals.
Well, it looks like they go inside.
They do. They actually fit right here, because you see there's this jump from 56 to 71, right? So 57 through 70 are all down here. And then 89 through 102 are down here, because they fit right here between 88 and 103. These, they're kind of crazy. We're not going to talk about them very much, but that's exactly where they would fit. They're also metals, and they would go in this area.
Oh, okay.
Okay, so we talked about the transition metals. That's these guys right here in the middle of the periodic table. And in those we have our most common heavy metals that you've probably heard of, like silver and copper and iron and zinc. Those are all transition metals that show up in the middle of the periodic table. Now, after the metals, on the right-hand side of the periodic table, we start getting our non-metals. And that's these over here. These guys, on the right-hand side, these are our non-metals. So anything that's not a metal goes over here on this side.
Is there some kind of break area that I might kind of see where the metals are and where the non-metals end?
Yeah.
But it looks like they just kind of flow together.
They do it does look like that. Is this line right here, this black stair-step line, this is the divide between metals and non-metals. This stair-step line right here.
So those are kind of metal-ish?
We call them metalloids.
Metalloids.
Yeah. Things that are kind of like a metal, we say metalloids. And it's everything that shows up on this stair-steppy line. It would include this guy right here. That one is a metalloid. Germanium and arsenic. Those are metalloids as well. And silicon and boron. Okay, so these guys that I highlighted green, those are metalloids. They have, they behave sometimes like a metal and sometimes like a non-metal. Like they have some characteristics in common with both. Metals usually think of as being like shiny and malleable and ductile, conducting electricity. Non-metals don't do any of those things, right? They can't conduct electricity. They're usually not bendable, malleable, you know. Well, metalloids will have characteristics of both. Sometimes they conduct electricity or like conduct it a little bit. They might be a little bit malleable. So they kind of look like both. They're like a hybrid, sort of. But so they show up right here in the middle. Okay, those are metalloids. And then the non-metals are everything to the right of the stair-step line. Everything on the right-hand side is a non-metal.
It looks like a lot of them are gases.
Yes, that's right. Yeah. Like you have nitrogen and oxygen. Those guys are gases. So is chlorine. Actually, these in this group right here, those are what we call the halogens.
Is there anything special about halogens?
Nothing that we need to talk about right now, but that's just what that group is called. Oxygen falls in that group. And you do have fluorine's group right here. These are the most some of the most reactive nonmetals. They love to react with our metals over on our alkali metals over here on the left-hand side of the periodic table.
What about this group right here? Is this a really reactive group?
Actually, that group doesn't react with anything at all, ever. Oh. These are the noble gases. So all of these guys, group 18, all the way down, these don't react with anything. They just love hanging up by themselves. They are, they have all 8 electrons that they need, which we'll talk about later on. They don't need to react with anything. They're perfectly happy just hanging out on their own.
So it's kind of like they're called noble because they don't want to have anything to do with any of the other elements.
Yes, that's right.
The unwashed masses.
That's right. So that's what these guys are right here. So I want you guys to remember, that the non-metals are on the right-hand side of the staircase line. The metals are on the left-hand side. And the metalloids go right here in between. Okay? Right. And the periodic table is pretty cool in that, like, all the groups kind of have the same properties. Mm-hmm. Everything that's in the same column behaves the same way. And even though, the way that it was put in order, like originally, was by increasing atomic number, which is pretty cool. Properties just kind of fell that way on their own. Yeah.
So because Mendeleev kept the properties in mind, and then Moseley just kind of put all the atomic orders, numbers in order. They just kind of felt where all their properties lined up. That's pretty neat.
Yep. So periodic table is a lot cool the more you know about it.
Yeah, it's very cool. And now we know.
Now we know.
All right.